My name is Muhammad Haziq bin Khairil Azri.
Today I will explain about question 3. Question 3 shows a voltage divider by a circuit for J-FET. Today I will explain how to determine the VGSQ, IDQ, VDS, VD, VG and VS. First, we need to find the VGSQ and IDQ first from the graph. For the curve of the graph, we just need to use the IDSS and VPP given, which is 10 mA and negative 3.5 volt. For the straight line, the first thing you have to do is make sure the ID equal to 0. When ID equals to 0, so use the formula VG equals to R2 VDD over R1 plus R2, and it will get 1.98 volt. Then make the VGS equal to 0, and then use the formula ID equal to VG over RS, and then we got 1.8 milliampere. Now we look at the graph. If we look closely at the graph here, this is the straight line and this is the curve that we have. So the function of this graph is to search for the operating point or the Q point. The straight line that intersects with the curved line, it is the operating point. So we all know that VGSQ is equals to negative 1.35 and IDQ is equal to 3.2 milliampere. After you got that value, sub in the value in the other formula. So for VDS is equal to VDD minus ID RD plus RS. And sub in the ID, and we got 9.44 volt. For VD is equals to VDD minus RD times ID, the same one. Just sub in the ID, save as VS, submit ID, and we got 3.52 volt. So now we take a look at the simulation value for the circuit. Now for VD, I got 13.055 volt, VS 3.473 volt, VGS negative 1.316 volt, and VG 2.157 volt. And for IDQ, I got 3.22 milliampere. Last but not least, I got 9.582 volt for VDS based on the simulation system by using multisim. As we can see here, the simulation and the mathematical value are slightly different. The reason is because for the calculation, doing a graph will make it less accurate because it depends on the graph at the curve. Doing a graph will make it less accurate because it depends on the curve at the graph. There will be inconsistency at the curve that make the value change constantly. And also, the graph is human made, so it is not perfect because of human error. For the simulation, it will calculate based on the simulation system, so the value will be the same no matter how many times you do the simulation.
Hi, my name is Muhammad Zahir Rizabidin, metric number B08191024. Want to present about J-FET self-bias circuit. Okay, from this question, J-FET self-bias circuit. So the question is, refer to the circuit in figure 2, determine the VGSQ, IDQ, VDS, VD, VG and VS. So this the circuit that question given. So for the first, we need to plot the graph. Okay, when plot the graph, so we can know the value IDSS in 6 milliampere, VP is negative 6 volt, and we need to calculate the VGS. So the VGS is negative ID times RS, the formula. If ID is 4 milliampere, we take the formulas for the value of ID, we just assume. So we can get the VGS is negative 6.4 volt. Okay, so we need to create the table. Alright, I want to present about how to create the table one by one. So for the first, if VGS 0 volt, the formula is ID SS times 1 minus VGS over VP squared. So we can get the value is 6 milliampere. 1 yes, we can get this plot graph, this graph, and 4 is this 4 milliampere ID. So we line, and this negative 6.4 volt, line. And we create the line linear, we just do, and we can get the IDQ 1.7 ampere and the VGSQ maybe 2.8 ampere. Alright. For the net solution, for the mathematical method, calculation method, okay, from the graph we can get VGSQ negative 2.8 volt and DQ 1.7 milliampere. For the VDS, the formula is VDD negative ID in bracket RS plus RD, we can get the value is 5.54 volt. And for VD is VDD negative ID RD, so we can get the value 8.26 volt. And for the VG is 0 volt. And for the VS, for the formula of VS is ID times RS. We replace the value and we can get 2.72 volt. And for the simulation multisim, okay, for the multisim, for VGSQ we can get negative 1.972 volt. And for the IDQ we can get 1.234 milliampere. Alright, for the VDS, when we create the simulation, we can get 7.33 volt. For the VD, we can get the value 9.297 volt. And for the VG, we can get 0 volt. And for VS, we can get from our simulation 1.966 volt. Alright, thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fikri bin Ridwan. My matrix number B0819101003. I'm from Faculty FTKE/BEEI. My class S1/1. Okay, today we'll talk about J-FET fixed bias circuit. Okay, from the given circuit below, we know that the IDSS is 8 milliampere, VP is negative 4V. So the question is, find the VGSQ, IDQ, VDS, VD, VG, and VS. Okay, how to find the solution? This is the calculation. Okay, first we know that we can find the VGSQ. Okay, the formula is VGS equal to negative VGSQ. Therefore, VGS equal to negative 4. You can see that that is the voltage. Okay, then we know that the VG equal to VGS, so it is same as negative 4. Alright, how to find the IDQ? Okay, IDSS 1 negative VGS over VP square. So we know that the IDSS is 8 milliampere. 1 minus negative 4 over negative 4 square, the answer. Okay, then we know the IDQ 8 bracket 1 minus 1 square, the answer is 0. Okay, how to find the VDS? formula is VDS big or equal to VGS. Okay, we know that VDS equal to 0 volt, so VGS minus VP. Then we got the 11 volt minus 0 volt equal to 18 volt. Okay, how to find the VDD? Okay, VD equal to VDD minus ID times RD. Okay, from the given, we know that it's equal to 18 volt. Okay, I will show how to find the VG. We know that VG equal to VGS, so it's equal to -4. Okay, VS equal IDQ times R. So we know that the IDS is 0, so the answer of VS is 0 ampere. Okay, for the multi-sim result. Okay, first you can see the result for VS 0 volt. Okay, second you can see the result of VD 18 volt. Okay, thirdly result IDQ 0 ampere. Then result VGSQ, you got negative 3.992 volt and VDS 18 volt. Okay, that's all. Thank you for me.